Hello, and welcome to Astronomy 100. In the previous segment, we talked about how the Earth orbiting around the Sun creates a problem when it has to do with the length of time that it takes compared to our calendars, and how we try to fix that problem by using the leap year system. In this segment, what we're going to do is talk about why the Earth experiences seasons. Now, let me remind you of an important point, that when it comes to the topic of the seasons, there are many people who think that they understand why the seasons occur, but when it comes to their explanation, it turns out to be incorrect. So what we're going to do in this segment is we're going to talk about all of the factual information that's related to how the Earth orbits around the Sun. And then what we're going to do is present the two different alternatives. One is the explanation that many people mistakenly believe when it comes to the cause for the seasons. And then we're going to talk about the correct interpretation of all of these visual facts related to what the Earth is actually doing to create the seasonal changes. So in this segment, what I'm going to do is lay out for you the facts of how we would see the Sun as we see it in the sky throughout the year that ultimately becomes the information needed that will tie together to create the seasons. And so there are 5 things that we're going to discuss, and I'm going to lay them out for you one at a time. And so let's begin with our first one. The first thing that you would notice if you had the ability to go outside on a regular basis is that when the Sun rises and sets each day, it does not rise and set in the same position along the horizon. In this image here, what we're going to see in a moment is how the image of where the Sun rises or sets along the horizon is going to be different each day. And the way that we're going to get that point across is I'm going to show you an animation. Now let me set this up a little bit. What you're about to see is a series of pictures where somebody went outside on a regular basis, maybe every 3 weeks or so. They stood in exactly the same spot and they took a picture of the sunrise. And in the picture that you're about to see, the animation you're about to see, what we're going to start off with is at the very center of the picture is looking due east. And then if you understand your compass points, when you look due east, anything to the left of that in this picture is going to be what we call north of east, or the combination of north combined with east, or northeast. And then anything to the right of this is going to be the combination of due east as well as south, combining east and south together, we get south of east. And so keep that in mind as we go through these images. Now, when I take all the pictures that were originally taken and string them together as an animation, what we end up with is this. And we'll let this run for a second and we'll kind of talk our way through this. What I want you to notice is the position of the sunrise as each of these photographs was taken is changing quite dramatically. You'll notice that the sun can rise very, very far south of east, and then it can also rise very far north of east. And then there are several occasions where the sun rises due east. Now, if we add these up, for instance, the extreme south of east position, the extreme north of east position, and then you'll notice that the sun passes through due east twice. These 4 positions are the reasons why we have 4 seasons. And so what we're going to talk about is the connection between where the sun appears to rise along the horizon, and then the calendar dates that go with these positions, and then of course the names of the seasons that accompany these. So I'm going to step through the individual pictures and show you these and tie all these things together. So let's start with the first picture here. What I want you to notice is in this first frame, the sun is rising quite a bit south of east, and this is as far south of east as the sun will get when it rises for the entire year. Now, when the sun does this, this occurs on the calendar on or about December 21st. And sometimes it's the 22nd, sometimes it's the 21st, so that's why we say on or about the 21st. Now, when this occurs, this is the first day of winter, and we call this the winter solstice. So on or about December 21st, the sun rises about as far south of east as it can get, and this is the first official day of winter, the winter solstice. But then you'll notice that the days following that and the weeks following that, the sun is going to rise in a position that is working its way closer to due east. There will come a day when the sun will rise exactly in the east, and this occurs on or about March 21st, sometimes the 22nd, but on or about the 21st, and this is the first official day of spring. Now, instead of saying spring, we call this the vernal equinox, and in a few minutes I'll explain to you what an equinox is. Now, as the days and weeks go by following that, what we find is that the sun continues to rise further and further north of east until there will come a day when the sun is going to rise as far north of east as it can rise for the entire year. And this occurs on or about June 21st, and this is the first official day of summer, and we call this the summer solstice. Now, every day following that, the sun is going to turn around along the horizon and work its way until, for the second time for that year, it is going to rise due east once again. Now, this occurs on or about September 21st, and this is what we call the first day of autumn. You might refer to it as fall, but the first day of autumn, and this is called the autumnal equinox. And then every day following that, the sun just continues to work its way south again until it rises south of east, and we repeat the cycle all over again with the winter solstice. So the winter solstice, the vernal equinox, the summer solstice, the autumnal equinox, all the way back to the winter solstice. And each of those 4 seasons marks the point where the sun is rising in a particular place along the horizon that marks the season that is at hand. Even though the set of images that I've shown you is for sunrises, we would get the exact same phenomenon if we were looking at sunsets. So the sun rises and it sets at different places along the horizon each day. Now, before I go on to the next topic, or at least the next observed fact, what's really critical to understand is that if the sun is going to rise in one particular place along the eastern horizon, it will set in the identical place along the western horizon. So an example is, if the sun rises north of east, it will set north of west. If it rises due east, it will set due west. And if it rises south of east, it will set south of west. Sometimes people get that mixed up. They think it's a crisscross, north of east to south of west, but it's not. North of east, north of west, south of east, south of west, due west. So make sure you understand that it's exactly the same position along the western horizon for sunsets as it is for sunrises. Let's go to the second observed fact about the sun. If you were to go outside on a regular basis, what you would also notice is that where the sun crosses the meridian each day is going to change. Now, to understand this fully, you have to remember the concept of the meridian. This is from a previous segment when we defined the meridian as the point, at least the line I should say, that crosses the sky that goes from the point of due east through the point straight overhead to due south, through the point straight overhead to true north. And remember, this line that crosses the sky, cutting from south through the point directly overhead to true north, this line is called the meridian line, and it divides the sky into an eastern half and a western half. Now, what I want you to notice in the sequence, and it's a little confusing because of the animation, but what I want you to notice is the position where the sun crosses the meridian is changing throughout the year. And in a minute, we'll come back to this. But before we dissect this animation, I want to show you a very interesting picture that was taken by somebody. And to fully understand this picture, this is what we call an all-sky picture. And what is happening is the camera that is taking this picture is laying on its back, and the lens is pointed towards the sky. And so it is a special type of lens called a wide-angle lens that allows you to take an image of the entire horizon. So when you look all the way around the perimeter of this picture, it is the entire horizon, north, south, east, and west. And what I want you to notice is the sun, as it crosses the sky, is going from one horizon to the other. And you'll notice that it crosses the sky in 3 different ways. So let's put a few lines on here to help us understand this. Now, what I want you to notice is we've drawn the meridian line. Remember from just a moment ago, the meridian is this imaginary line that goes from true south all the way through the point straight overhead. If you recall, that's called your zenith, all the way to true north. So this point right here would be directly overhead if you were looking out and looking up at the sky. What I want you to notice is the sun rises on this particular day north of east. It's going to cross the meridian right here, and then it's going to set north of west. So this is a series of pictures of the sun that somebody took over the course of the entire day. Let's say about every hour or so, they came outside and took another picture. And you can see the entire sequence here. Now, on a different day of the year, the same person came out and did the exact same thing again. But what I want you to notice is, on this particular day, the sun is rising south of east. It crosses the meridian here, and then it sets south of west. And then on yet a third day of the year, the sun rose exactly in the east, crossed the meridian at this point, and then set exactly in the west. So let's tie these observations to the actual dates on the calendar and the seasons. This first set of images right here, when the sun rises north of east and sets north of west, this was taken on the day of the summer solstice. This would be on or about June 21st. And what I want you to notice is the altitude of the sun at noon was very, very high. It was not directly overhead, but it came very, very close to that. So the sun's altitude when it crossed the meridian was very high. Now this one on the bottom here, this sequence on the bottom was taken on or about December 21st, which was the winter solstice. Rises south of east. Notice it crosses the meridian with a very low altitude, and then of course sets south of west. So what we end up getting is the sun not reaching very high in the sky during the first day of winter, and the sun reaching very, very high in the sky on the first day of summer. So this idea is related to a term that we're going to introduce at this point that is called local noon. And local noon is defined as the time of day when the sun is crossing the meridian. So every day the sun has to cross the meridian, and at the point when the sun does that, we call that local noon. Now keep that in mind as we go back to this sequence. What I want you to notice is on this particular day, the summer solstice, the sun at local noon, crossing the meridian, was actually very high in the sky. The altitude is quite high. And on the day of the summer solstice, the sun rose north of east, and it's going to cross the meridian very high, and it's going to set north of west. But later on in the year, and you notice it just says equinox, it could be either one. It could be either the vernal equinox or the autumnal equinox. But on either one of those two, the sun is going to rise due east, it's going to set due west, but notice that when it crosses the meridian, the altitude is not as high as it was on the day of the summer solstice. And then finally, the third one is, on the day of the winter solstice, the sun is going to rise south of east, it's going to set south of west, but notice the altitude was very, very low. So throughout the year, the altitude of the sun at noon is going to change. At local noon, the altitude is constantly changing. The maximum altitude it'll reach for the entire year is on the day of the summer solstice, and the minimum altitude that it'll reach for the entire year is on the day of the winter solstice. So these first observed facts about the sun are related to the concept of the seasons. We do have a few more to go through before we can tie all of this together and understand the full nature of the seasons. But we're running out of time, so we'll save the rest of this for the next segment. I hope you'll join me.